So here is the quick revision of our Michaelis Menten equation. Our enzyme substrate reaction is a two-step reaction in which enzyme and substrate will combine to form an enzyme substrate complex, and it's a reversible reaction. So we have taken two rate constant. For forward reaction, rate constant is K1. For backward reaction, rate constant is K inverse. And this enzyme substrate complex gives us product, and the rate constant we have taken is K2. The rate of a reaction can be explained in terms of rate of formation of product with respect to time. So that will become our K2 enzyme substrate concentration. But we do not know the enzyme substrate complex concentration. In order to find out that, we are applying steady state approximation onto the concentration of our enzyme substrate complex. This we can understand from this graph. This is a plot of concentration with respect to time. So concentration of substrate decreases with the course of reaction, concentration of product increases, but the concentration of our intermediates initially increases, then becomes constant. This becoming of the constant concentration of ES represent the steady state approximation. What it explains is the rate of change of concentration of enzyme substrate complex with time is equal to 0, or we can say rate of formation of enzyme substrate complex is equal to rate of decomposition of enzyme substrate complex. So rate of formation happens in the forward step of the first step of the reaction. So enzyme and substrate combines to give us enzyme substrate. So we can write the rate as K1 enzyme concentration into substrate concentration. This we write down as equal to rate of decomposition of enzyme substrate. So enzyme substrate is decomposing in two steps. First, the backward reaction, and other is the second step. So the rate of backward reaction is equal to K inverse and enzyme substrate concentration. So we have written here K inverse enzyme substrate complex concentration plus K2 enzyme substrate concentration, that is rate of reaction of the second step. So this we have written. Now this E represent the free enzyme concentration. That free enzyme concentration is equal to the total enzyme concentration minus enzyme substrate complex. So we in place of the free enzyme concentration, we are writing total enzyme concentration minus enzyme substrate complex. And after doing mathematics, we have find out the enzyme substrate concentration in terms of our total enzyme concentration, substrate and rate constants. So on rearranging, we got this third equation. Now we put the concentration of enzyme substrate complex from third equation to our first equation, and we got this equation. This represents the rate of reaction. So here I have written R, and this right hand side is same, K2 and our value of ES. So here this complete term is constant. So instead of this, we are writing Km, where Km is equal to K inverse plus K2 divided by K1. This represents the Michaelis constant. This is called Michaelis constant. Alright. So instead of 3 constant, we are writing Km. So our equation becomes rate of reaction is equal to K2 into total enzyme concentration into substrate concentration divided by substrate concentration plus Km, and this equation represents the Michaelis Menten equation. We will be discussing the different cases of this in the further next video.